Okay, Darlene.
Great. Well, thank you very much for joining us. As John said, we have set up a series of geoheritage talks. They're going to be running for the next 4 weeks, starting today with today's talk by Bruce. Next week is the Life and Times of Andrew Geddes-Bain, and that's by Camille Clark. Then Tony Boniface will give us the history of South Africa's first geological map. And Catherine James Kleinons will end with the early days of Johannesburg and the Witwatersrand gold mining. So it's something that we're very excited about. We probably will add more talks going forward, but hope to see you all in the next 4 talks. Thanks, Henny.
Thank you very much. It's now my honor and privilege to introduce Prof Cairncross, who obtained his master's degree from the University of Natal in 1979, and after a stint with Rand Mines Limited, joined the University of the Witwatersrand, obtaining his PhD in 1986. He then joined the Rand Afrikaans University Geology Department, where he served as head of department for 14 years, from 2003 to 2016, during which time Rao merged with Witwatersrand Technikon to form the University of Johannesburg. He is now Emeritus Professor of Geology at UJ. Bruce has written 12 books on Southern African minerals and gemstones, authored and co-authored 240 articles, and presented over 100 public lectures on the same topics. He's a recognized expert on photographing minerals and gemstones and has won local and international awards for his work. He was awarded the Geological Society of South Africa's Presidential Award in 2009 for services rendered to the Johannesburg Geological Museum and South African Mineral Heritage. In 2020, he was honored with the GSSA Draper Medal for lifetime achievements and contribution to South African geology, geoheritage, and tertiary education. Bruce has served the GSSA in various capacities. As an elected council member, the Honorary Secretary of the Sedimentology Division for 11 years, the Conservation Committee, the Centennial Coordination Committee, the Activation Committee, and the Professional Affairs Committee. He is a past Vice President of the International Association of Sedimentologists and continues to serve as a member of the Johannesburg Geological Museum Association Committee that he has chaired for 10 years. When not pursuing mineral-related matters, he plays the guitar and is a life member of the Guide Dogs Association of South Africa. Welcome, and over to you, Bruce.
Many thanks very much. Let me share my screen. This. You can see my first slide?
Yes.
Okay. Well, thanks for that introduction. It's much appreciated. As Nolene said, the next few talks are going to be on geoheritage. So in a sense, my talk today is a little bit about that, because it is about what is called portable geoheritage. In other words, things geological that can be transported around. And that's where basically minerals and gemstones would, in fact, come into the picture. So I don't think the Kalahari Manganese Field needs any introduction to any South African geologist or even overseas geologist. It's quite well known. It's world famous. But perhaps what isn't that well known amongst the geological community is the mineral specimens that the mines have produced there from the 1960s. And some of these are truly iconic, and they are specimens that are desired by museums and private collectors around the world. And some of them are truly iconic. And the most famous is actually the manganese carbonate that comes from there, the rhodochrosite, the red crystals. So my talk today is, I'm going to briefly talk about the history of the discovery of the manganese fields and briefly about the geology, but really the focus is going to be on the minerals that come from there that are famous, and others. For example, there are some type locality species that were discovered there and that are still unique to that deposit. They haven't been found anywhere else in the world. So just before I start, I would just like to acknowledge a few people and organizations. Firstly, ASOR and ASMANG and their chairman, Mr. Desmond Sacco, These companies have actually sponsored the 2 books that myself, Jens Gutsma, and Nick Bierkes have done on the Kalahari Manganese Field and the Postmasburg area as well. So that is greatly appreciated. And then my two colleagues, Nick Bierkes, Jens Gutsma, and all of their postgraduate students who have basically, they are the ones who have worked up the geology and tried to understand the origin and the evolution of these deposits. That's really their forte. I have a bit of knowledge on that, but really it's the minerals that interest me. And then an individual, Paul Balier, who during the early 2000s had an official contract with the Nchwaning mine to mine for specimens, which was sort of a unique event here in South Africa, but not unique elsewhere. There are these collector companies that operate, for example, in America, that get contracts to mine purely for minerals. And I'll show you some of the specimens that have come out from his efforts a bit later in my talk. And then also the various collectors who have allowed me to photograph their specimens. Quite a lot of mine, but quite a lot are not. And then also just my research funding. I think I must acknowledge Samira, which is the DSI NRF, the Center of Excellence, co-hosted at WITS and actually centered here at UJ. And then also the NRF, which over the many years I've received my funding from. So this is basically the schedule that I'll actually follow. As I say, a brief history and a brief geology, and then have a look at some of the famous minerals, one of which is in the background of the slide, rhodochrosite, and then some others. And then in the last 20 years now, 2 of the major finds in mineralogy from the mines, Shigaite and olmite, which probably sound a bit esoteric, but I'll just talk a bit about those, and then end with a few slides and some interesting information about a couple of the type locality species. Okay, so this is a slide I used actually for a talk that I gave last year and for a meeting in America, but if most of the audience are in South Africa, you probably don't need to be told where the Kalahari Manganese Field is. It's in the Northern Cape Province. It sits north of the town of Kuruman, and one drives up the road about 60 km to Hotazel and to Blackrock, the 2 mine villages. So that's where it's located geographically in South Africa. Now, the history of the Kalahari Manganese Field is in essence also related to the history of the Postmasburg iron manganese field, which is found to the south of the Kalahari Field. And in fact, developments actually happened there, and then they also then spread north to the Kalahari. And in the background here is one of the early maps to the south of the Kalahari by Orpen, which he did on the physiography of the area in 1872. But for the Kalahari Manganese Field, the first geological work really was done by Rogers in the early part of the 20th century, where he mapped the area, and there's very little outcrop there apart from the small hill at Blackrock that I'll show you in a while. And he gave a first description actually of the rocks outcropping there, which was the manganese and the iron ore. But apart from the mapping, there wasn't really any development. And then in the ensuing years, there were more reports done by the Geological Survey, by Schoen, Hall, and others. But it wasn't really until 1928 when a young mining geologist came out to South Africa from Italy, Guido Sacco, who's the father of Desmond Sacco. And he came out here seeking his fortune, I suppose, and in essence was the kickstart of the manganese mining era in the Kalahari Manganese Field. But starting first in 1928, when he formed the Gloucester manganese mines down south in the Postmasburg. But then in 1940, after taking up options in the Kalahari, he opened the Blackrock mine, which was opened on the actual hill, the Blackrock Hill. So that's sort of the early part of the discovery from a geological standpoint. From a mineral standpoint, you know, mineral collectors are always interesting. They want to know the provenance. Where do the specimens come from? So the Hotazel mine, those first rhodochrosites actually came out in the mid-1960s from the Hotazel mine. And then following that into the 1960s and the 70s and the 80s, the various mines which are still operating there now were open. The Mamatwan mine, the big open pit mine to the south of the manganese field, and then the Nchwaning mine, the Vessels mine, and then Entwining 2 and Entwining 3. And you'll notice during this period that basically there were only two players in the game, Samancor and Assmang. But following the New Minerals Act in 2004, which opened up the area, more players came in. And apart from those two big companies, there are now obviously other mining companies that are operating in the area. But you know, the history of the region actually has been covered in quite a few books. There's this one book here called Changing Tides, which is the story of Assmang. And it was an in-house publication done by Assmang. And then followed later by the Kumani book, which is the iron ore, also Assmang. But then there's this book, which is kind of old. It's up to 1976, but the story of manganese, but actually Samancor. So if anyone is interested in really getting into the detailed history, a lot of information can be found in these publications. And here's two late 1950s, early 1960s slides from Avman of some of the open pit mines at the time. This is the Devon mine, where they're mining quite close to surface. And this is the Adams mine with the feeder conveyor belt going along here. So these were some of the early mines that were mined on surface, whereas there are mines now which are both on surface and underground. So Black Rock, this is the first detailed geological map. It was mapped by Rogers, but Boardman in 1940 produced the map you see here on the left. And there's a scale up at the top that's actually 600 feet. So this is the Blackrock Hill. So it's essentially about 400 or 500 meters long. And it outcrops at the triple junction point here. That's the trig beacon on the hill. And of the three farms, Entwining, after which the mine's named, Santwe, and Belgravia. And if you just look at this map, you can see the black here shown as the hematite ore, and the horizontal or the oblique black ions are the manganese ore. So this was Boardman's early map of the mine. Now the next slide I'll show you will be a view looking in towards it here. And first of all, the one at the top is out of one of those books. It's essentially in the 1940s with a farmhouse in the front. So there's the hill. That's the Blackrock Hill. And then down here is a more recent view where you can see some of there's a reservoir and radio tower, and you can see some of the adits here going in the side of the hill. So that basically is Black Rock. Now this chart, which is a little bit busy, but it shows you a couple of things. First of all, there's a time period along the top from the early 1930s, and this ends in about 2015. And all of the mines that have operated up to that period, and whether they were underground or open pit. And you can see, for example, Black Rock was both, whereas Smart and Perth are only open pit. And down here in the more recent times, Entwining and the Vessels are all underground. And the companies that operated them. As I say, until 2004, you can see it's like a two-man band. And then later, and again, there are even more operators than are shown on this chart. It also shows in red and blue the two types of ore that occur in the manganese field. And I'll be discussing this in a short while. There's the so-called low-grade ore, which is the blue. So Mamatwan essentially mines low-grade ore. And there's the red, which is the high-grade. And obviously that's what the mines would like to exploit if they can. So, okay, from a mineral standpoint, Hotazel mine, Entwining and Vessels, Entwining 2 and Entwining 3 are really the ones of some interest. But just having a look at this low-grade, high-grade ore. Okay, so there were 22 mines operating. There's actually more operators now. And in fact, I think Sitatunga is opening or has just opened a new mine close to Hotazel, East, I think it's called East Manganese. So there's still new development going on there. But the manganese ore, that's the Gloria mine in the background with the ore piles. Essentially, there's what's called low-grade ore and high-grade. And so the low-grade or the primary ore, the sedimentary and early diagenetic ore, in other words, this is the manganese that precipitated when the sediments were deposited. It's about 30 to 38% manganese. Whereas the high grade, what's called the Vessels type ore, 42 to 60%. And you'll see in a while the vessels type ore is the major role player, where a lot of the secondary type of minerals are found. And it's been often stated that the Kalahari Manganese Field is the largest land-based resource. There are obviously the manganese nodules on the seafloors, but is still to date the largest resource for manganese. So here's a Google Earth image looking from south to the north. So Kuruman would be off to the bottom, and it shows some of the mines. So here's the Mamatwan open cast mine, Adams, Smart, the UMK mine, and then up in the north here, towards the north of the field, are the vessels and the various Ntwaning mines. So if you just zoom in to that block, here they are. So there's the vessels mine with its footprint. Here Ntwaning 1, 2, and 2, and here is Ntwaning 3. And there, just over there, that is the Blackrock Hill that you can sort of see vaguely in the distance. So here's Mamatwan mine, a big open cast mine, mining essentially the low-grade ore, large tonnages. One of the main minerals in the Kalahari Manganese Field is Manganite, and it occurs in a massive state in the ore, but it also occurs as very beautiful secondary crystals. And what's interesting, and I always like to mention this, is that in 1984, there was a commemorative series of stamps that were produced for South Africa featuring some of the resources that we have: diamond, gold, iron ore, platinum, and manganese. And this was the stamp for manganese. And in fact, in the background, yeah, that's the Mamatwan mine that you can see in my slide. And in each of the stamps, the artist used a mineral specimen to depict something aesthetic. So in the front here is a manganite specimen. But unfortunately, that specimen comes from the Harz Mountain in Germany. It's not from the South African deposits. And how we know that is the habit of these crystals, which are more or less columnar, which are iconic for that deposit in Germany. So I presume the artist must have found a book of mineral pictures or whatever and decided to paint this manganite without knowing it should be a totally different form of the crystal. So that's a bit of a quirk in the stamps. As I mentioned, there's very little outcrop in the area. This is the road driving up from Kuruman to Hartbeespoort. If you've ever been there, it's rather featureless, dry usually, although not always. Paul Balier took this slide in 2008, where there was heavy rains in the area. So it's not always semi-desert as one thinks of the Kalahari. And in fact, there's been quite a lot of rain there the past few months towards the end of 2021. Okay, so here's Blackrock, seen from a small aircraft. And again, it's not a very large outcrop. And the next slide I'm going to show you will be taken down inside one of these adits as you go down into the old Blackrock mine. And just in the foreground here, this is the village, the Blackrock. That's the village for the mines, for people who work at the Ntwaning mines for Aspang. So here's the old underground workings. And here's a man for scale standing down below here. So these are the support pillars, huge. Because, I mean, the scale is quite staggering when one sees this. And these are the remnant pillars from the old Blackrock mine. And you can also see here, the strata are dipping quite steeply to the west. And I'll come to that in a short while as well. So here's an Ntwaning mine, the headgear with some of the conveyor belts. There's also a decline shaft as well as the vertical shaft. And Ntwaning mine has produced a mineral specimen called Ntwaningite, which is named after the mine. It's a manganese silicate. And it's this is quite small. It's under 2 centimeters. It's these little brownish fibrous puff balls. So that's a mineral that was discovered here at Ntwaning and named after the mine, Ntwaningite. There's the Vessels mine, which is just adjacent to Ntwaning with its headgear. And there's also a mineral named after this mine. It's called Vesselcite, which again was found at the mine here, associated with, as you can see here, some quartz, and the purple is actually Sugilite, and it's a strontium copper silicate. You can kind of start to see things here with, if you talk about alteration and secondary minerals, you know, strontium. So the Vessels mine and Ntwaning mine are two separate companies, but they essentially mine the same ore body underground. They haven't always produced the same specimens though, which is kind of interesting. And they, in fact, the vessels mine used to, and I'm not sure if it still does, it mines a little bit more of the main ore body. But going to look at the geology underground, as I said, I'm just going to cover this rather briefly or generally because my colleagues are really the experts on this. But in the background is a vertical strat column here, for the hot as hell formation. So if we just have a look at this in a bit of detail. Okay, so again, there's quite a lot on the slide, but it does show a few things I'd like to talk about. First of all, here's a scale, so that's 20 meters. And here's the ongeluk formation below in green, then what's called the hot as hell formation, and then overlain by the Moidrai formation. And essentially, the stratigraphy below are the ongeluk lavas, and above are the carbonates, the limestones, and the dolomites. And the hot as hell formation is the one that contains the ore bodies, both iron formations and also the manganese ore bodies. So there are actually three main deposits or layers of manganese, Mn1, Mn2, Mn3. And the main one below, Mn1, is the one that is actually mined. Although there is some interest expressed also in the ones above as well. And then on the right-hand column here are some of the lithologies described by Gunsma et al. And on the right, I've just actually shown a few pictures. These are polished pieces of 2.5 centimeter diameter core, just to show the various rock types. For example, this is the jasperite here at the base of the hot as hell formation. Then these here, this is that's again an iron formation with not much in the way of jasper. Then these hematite, lutites, the braunite, the manganese ore, and then above some of the dolomites. So that's really the lithologies and the stratigraphy. But apart from that, the other very important aspect of the Kalahari Manganese Field is the structure. And this here is a cross-section from east to west. So it's going from Nchwaning in the east, Nchwaning 2 to Nchwaning 3, to the hill here at Blackrock. So just to put that into context, here's a slide. So I'm actually standing at the beacon on this little peak here, looking towards the east. So there in the distance, that's Nchwaning 2. This is Nchwaning 3 here, and this is the hill. So that's basically the section. Now, and here's the stratigraphy again. So the red and the black you see here is the hot as hell formation, and there's the green, the ongeluk below. And then above that comes the younger formations, including the Dwika, and then the Overberg and the Kalahari formation. But perhaps of critical importance to the discovery of the deposit is this structure, these structures here in the west. And these are basically thrust faults where there's been duplication of the stratigraphy below, and where parts of the hot as hell formation and the ongeluk have been thrust onto surface. And that's how Blackrock Hill came into being, due to the upthrusting and the compressional tectonics. So had we not had this, presuming, and of course we did have to have had it due to the tectonic evolution of this part of our subcontinent. But if we didn't, it would have meant that basically this would have remained undercover for who knows how long before it was ultimately discovered, and probably a whole lot later, perhaps using geophysics. But that's just by the way. So that's the one thing. The other important structure feature are these vertical, subvertical tectonics forming horsts and grabens. And for example, the Nchwaning 3 shaft is actually in one of these down-thrown grabens with a decline from 2 actually meeting at the bottom of the shaft. And the work by Gunsma and Bierkes and others has shown that these faults were the pathways along which the later mineralizing fluids and geothermal fluids passed that in effect upgraded the low grade ore into the high grade ore. So these structures are important, let's say, from the mineralization, not to say that these weren't either, but also these were important for the stratigraphy and the discovery on the hill. And so there's just again a scale on the left. So there is the stratigraphy. Here's just a plan view. So what we were looking at was up here in the north. So there's the Entwining farm and there's the Vessels farm. So that's up here. And you see it's got high grade ore. This is a map, again, that we did for our book. And again, from the standpoint of the companies, probably needs a bit of updating. But it does show the outline of essentially that low grade early sedimentary ore. And then the superimposition of some of the high grade ore on top of that. And you can see there's this area up here of high grade ore. There's some here to the west, but remembering the starter are dipping down towards the west, so that's fairly deep. And then over here, Hotazel itself, there's some high-grade ore as well. So how did this all come about? It's been a complex geological history and is shown pictorially in cartoons on the left. Essentially, starting up on the top left with the deposition of the sediments early on in the Transvaal Basin, 2.2 million years ago, A. And we follow an evolutionary path going B, C, D, winding our way down to the bottom down here. And there have been a number of structural and intrusive events with intrusive dikes, deformation, mineralizing episodes. And so the first important one is obviously that early deposition and the diagenesis of the primary ore. But the second, from the standpoint of the minerals, the portable geoheritage, is this what's been called the vessels type ore forming event. And it's been accurately dated. Nos, Armbruster, and Villa dated the Sugilite that is found in the ore, as well as a mica Rhodochrosite. It's a manganese lithium oxymica. And they got age dates of just over 1,000 million years ago and 850 million. And work done later by others have shown that many, many, many of the secondary minerals formed during this particular event. So a lot later than the early sedimentary and the diagenetic. But other events that were important are 500 to 600 million years, more or less the Gloria event, is so-called, the Smart event, when a lot of the Todorokite, that sort of asbestiform manganese mineral formed, and then also supergene ore formation. So that's really how things have developed from the Paleoproterozoic up until the more recent times. But let's look closely at this, because this is really about the minerals. So underground here, you can see some of that. So there's that little cartoon again showing you some of the faults with some of the mineralization that's permeating out in red. And yeah, underground, you can see a small-scale version of that. This is a vein, a vertical vein of calcite, which is cutting through the iron formation. That's about 2 meters across. And this here is a vein of solid pyrite cutting through the host rock. So there are these pathways that you can see there's been this alteration. And there's been lots of brecciation as well, actually fragmentation of the iron formation and the manganese ore body. And you can see that here, where it's now been cemented later by this pink manganese carbonate, which is the rhodochrosite. So we had the brecciation and the cementing. And wherever there's any cavity formation or any space, that's obviously where one has the ability to form euhedral, well-formed crystals, as you see here, as opposed to just the massive. Now, to support the claim that the vessels event is the one of the main, the genesis of the secondary minerals, if we just look at this little histogram, it's showing the amount of the manganese ore in percentage with 100 on the right. And you'll notice immediately that early diagenetic, the so-called low-grade ore, accounts for by far the bulk of the ore in the Kalahari Manganese Field. Again, these figures may need to be updated slightly, but the pattern is identical. And then later on down here, those events getting younger and younger account for a very small percentage of the manganese ore. But if we look closely at the vessels event, and we look then across at the mineral species, so here's a number of minerals up to 140. In the early diagenetic ore, there's only really 7 minerals found, and those are the manganese and a few of the carbonates. But in the vessels, which is only 3% of the ore, there's 140 of the known species, some of which are very esoteric, occur there. So although it's a small percentage of the ore, it's producing the bulk of the secondary minerals. The others also obviously produce, and in fact, some like the supergene alteration even have more than the sedimentary event. So that's really an important time. I must, however, state that recently we've, Professor Jan Kramers here at UJ, he dated some of the hydroxy-apopholites that actually come from there. And we haven't published the data yet, but they've shown, and they're beautiful euhedral crystals, they've shown a remarkably younger age than the vessel. So it seems that not all was happening during this early older event, but there was still crystallization, secondary minerals forming much later. So let's look at some of these now. And certainly the most famous, as I say, is the rhodochrosite. In the background is a specimen of these, they call dog's tooth type of crystals, coated with a little bit of white quartz on the manganese ore. Now, it's essentially a manganese carbonate. It's trigonal. It's a fairly soft mineral, although some of it has been cut and faceted into what are called fancy gemstones. And the Kalahari Rhodochrosite is world famous. There are other localities in the world. In America, in Colorado, the Sweet Home mine has produced rhodochrosite rhombohedral crystals up to 10 centimeters on edge, which are also iconic. But every curator, I'd say every collection, in a serious collection, tries to acquire a rhodochrosite, which is problematical because the best crystal specimens came out only really once in the mid-1970s when they went through the zone that contained them. It's come out in dribs and drabs, but not much actually since. And to justify my claim, he has just 6 publications: Mineralogical Record in America, the German Lapis, Rocks and Minerals in America. He has the show poster for the Tucson International Gem and Mineral Show, and there's our first manganese book. But all of these have got on the Enchuaning 1 rhodochrosite. And I think you don't even have to maybe know too much about minerals or mineralogy, but they are attractive in their own right. And in fact, when the first specimens started coming out in the mid-1970s, and they were actually acquired here, in fact, locally, but they were then obtained and sold to American dealers in minerals who took them to the Tucson show for the first time. And when they were put on display there, they were first thought to be fakes. They were thought to be just basically calcite crystals that had somehow been soaked in cranberry juice. And there was some opposition at first until they were obviously analyzed. And then, of course, it became a feeding frenzy with the collectors. In Peter Bancroft's Gem and Crystal Treasures book, where he features the top minerals of the world, he actually came to South Africa doing his work, and he spoke to who he calls the mine director. He doesn't name who it was at Enchuaning Mine, who then recounts how they hit these crystals underground, going to fantastic jewel-lined pockets in vugs of haussmannite with other minerals. And the most spectacular specimen then, I guess, was 0.5 meter by a meter that took 3 days to dig out. And in fact, that specimen was donated to the Ditsong, he says the Pretoria Museum, that's the old Transvaal Museum. And in fact, that's the specimen sitting there in the display case, which if you go to Ditsong Museum, you would see it. So that's the piece he actually describes. But let's have a look at some of these. This is one of the first and one of the oldest known, and it actually comes from the Hot as Hell mine in the early 1960s. There was a trickle of these specimens that came out, but really the big ones came out a decade later. And it's essentially gypsum. This is a partly formed crystal of gypsum on this botryoidal or druzy rhodochrosite. It's a 12.5 centimeter specimen. But really the ones that are popular, and I'll just run through these to show you them, are these almost like orange sweets, gel-like almost, also from Hot as Hell, a 7.5 centimeter specimen. some of the latest specimens are said to have come from Hotazel mine because they're older and have a better pedigree. But this actually came from a miner who worked at the mine. And this again is just 5 of the various habits of this mineral species. And that's what also makes it so attractive with collectors. It's not just scalenahedral dog's tooth, but you get beautiful, perfect spheres. These one on the left and the right that are zoned, they're called wheat sheath. They're like bundles of wheat that you see in the field, where the cores are opaque pink and the terminations are transparent red. And then this one here, which is showing that's about the size of my fist, showing a cluster of, again, scalenahedral, but the terminations on the end are flat. But this again is another one, really iconic, 8 centimeters with some like snow on the mountain peaks, quartz crystals on, and 4 others. And as I mentioned, sometimes they are, for the rare gemstone collectors, can be cut into gemstones. And this is a 24 karat rhodo cut from, usually when they cut, the cutters don't use beautiful aesthetic crystals which are perfect like this, but they take rather fragmented pieces. Here's some more examples again of some of the faceted stones. And because they are rare, they actually command a very high per carat price. In fact, often going up, believe it or not, to some of the prices for emeralds and diamonds amongst these specialized collectors. Here's another large plate, 16 centimeters of this really gemmy on manganite. These are all from the mid-1970s. Then there's this type, which is sort of coliform, almost like broccoli, where you can see again this like radiating from a point where he has a broken piece where the core is gemmy red, but then it's overgrown by a secondary overgrowth of this pink opaque. And a very large 30 centimeter slab, literally covered with what's called the wheat sheath habit on the manganite. It's also this combination of the different species that really make them aesthetically pleasing, the red on the black, for example, you know, the contrast. And these 2 famous specimens that were on show at the Munich show, the München Mineralientage, which is an annual German mineral show in Munich, the 2nd largest in the world. In 2012, they had Africa as the theme. And this is the Assol Company specimen that was on display there, 25 by 30 centimeters, a very big piece. And on the right, another Kalahari specimen. It's probably about, that one's probably about the size of my fist. And that's been called the Snail. And I just took this picture through the display case to show it, and that's it up close. And it's really iconic. It actually currently resides in the Bill Larson collection in California, but it looks just like a snail. The base has been sawn to be flat, but it's got this absolutely gem quality, three or four of the clusters on top. And that particular specimen has been shown on calendars, in books, on websites. It's really quite famous. But there are other types and habits as well, as I have mentioned. And here, these particular spheres or perfectly formed aggregates or balls, this is 12 centimeters, again, on the manganite from Nchwaneng mine. And then these 2, which look at like 2 soft marshmallows that are touching together. I took this slide in 1993 at the Tucson show. I was walking around amongst the dealers, and I just happened to see this in their showcase. It was for sale. I can't remember the price, but subsequently I discovered that it has entered the collection of a collector in America. And it appears they weren't that uncommon, because here's another one at the 2006 show I saw. Perfect, like a golf ball, pink rhodochrosite on the black, on the manganite. Then these rather strange ones, which look like fungi, like a mushroom. There's this spongy form, perhaps mangano pink calcite rhodochrosite, on which are perched these looking like mushroom aggregates of the pink rhodo, which are coated with tiny platy crystals of the manganite. Quite a strange habit. Here's another old one with a different habit. These are actually rhombohedrons that are very flat, and they are clustered together on a matrix of blue chalcedony with Manganite, actually Susmanite, and some white barite. That's about a 7 centimeter specimen. And then this one from the Vessels mine showing a plate of rhombohedral crystals. And in fact, if you look globally at rhodochrosite, rhombohedral forms are the most common by far, from America, China, etc. So the variety of forms and habits from the Kalahari is what also makes them very popular, that people try to get sweets of the different habits. Here's another one. This is a vug, a cavity at 5 centimeters, lined by these very acicular needle rhodochrosites that are color zoned from pink to amber. And sitting just down in the bottom right is a mineral called Shigaite. And that's what I'm going to speak about a little bit later. That's the Shigerite here. And this looking like a mold of rhodochrosite, tiny crystals draping and dripping over this brown velvet-like species, which is actually Sussexite. It's a manganese borate. So that's from Entwining 2. This is a more recent specimen. And in fact, this is one of the minerals which Paul Balier mined during his contract mining operation. These vermiform or worm-like rhodochrosite, again, the variety of forms and habits is actually quite diverse. And this little chimney, it's a hollow, perhaps some sort of a stalactite or stalagmite, and the front has been broken, so you can see the hollow inside like a little finger. It's quite small. It's only 2.8 centimeters. Some people have thought these might be pseudomorphous of rhodochrosite after something else, but I just think they probably some kind of a stalactitic primary growth. And then this small crystal of rhodo, what Europeans would call a farden. If you just have a look at it, it's got the terminations on both sides, but down the middle here is like a semi-opaque translucent zone. And what happens is that the mineral starts to crystallize here to begin with, and then it grows out at right angles as the development of the forms occur, and that's called a farden. And then this one here, the last one of the rhodos I'll be showing you, and the reason is it's not a very spectacular piece. It's quite small, only 2.3 centimeters, but it occurs with this fibrous todorokite, which is this asbestiform type of a manganese mineral. Now I'm showing it because some of the todorokite has been dated, and some of the rhodochrosite actually overgrows it. So obviously the rhodo has to, post-date has to be younger if it's got inclusions of the todorokite in it. So there's always been this question, you know, when did it form? Well, was it during the Vessels event? Was it during the SMART event, the Gloria event? Did it form then? Was it during the SMART event? And in fact, some of the todorokite during the so-called SMART event has been dated at about, and therefore, for this particular type of rhodo, now it may not be applicable to all of the older type or all of the other types, but it appears that it formed relatively late in the genesis of the manganese deposits because of this association and overgrowth with the todorokite. So that's kind of interesting to put a bit of a bracket on the age dates of these. Now to digress for a second, and as I think a lot of the audience is sitting down in the Western Cape, I've put this slide in, and if we were in a venue with an audience, I like to show it. And it's about 1.3 centimeters. It's a bit out of focus because it's a very old picture I took many years ago. And I always ask people in the audience, well, what do you think this is? You know, is it rhodochrosite? Is it inosite? Well, actually, it's neither. It's a tartrate from a bottle of Canoncorp pinotage that we had many years ago. And these crystals were actually at the bottom of the bottle as a tartrate. And I'd like to just kind of show that as a bit of a digression. Not all red is rhodochrosite. Nowadays, unfortunately, I can't afford the Canoncorp pinotage. It's become quite iconic wine. But a few other of the iconic including these like ice cream cone. This is cutnahorite, which is a calcium manganese carbonate that occurs at Nchwaning Mine. Here's another one. This is a large 21 centimeter piece, and some people think these look like orchids, like the flowers on an orchid. They're quite aesthetic. What's interesting is that they obviously get the pink color from the manganese, but if they are in a display case in the light, over time, they fade and they lose all their color and they turn white and become quite brittle, actually. Then this mineral, which is called Ettringite, named after the town of Ettringen in Germany, that's the type locality. But the Kalahari Manganese Field Ettringites are the world's best by orders of magnitude, these very large yellow crystals. This one with calcite and with manganite. And in the early mid-1980s, they came out in their thousands from the Nchwaning mine and also the Wessels mine. So these are really the best. Then these, which are maybe small, that's only a centimeter, this crystal, hexagonal. They look a little bit like Ettringite, but they are, if we just go back, this is a calcium aluminium sulfate. This is just a calcium sulfate, so without the aluminium. This is a mineral called Thomasite. And again, it's known as microcrystals elsewhere, but the Kalahari Manganese Field, these crystals, some of which went up to 4 centimeters, are the best known in the world to date. And then this mineral, Sturmanite, again, a calcium iron sulfate borohydroxyl, highly hydrated. Variety of habits, large crystals. That's a 14 centimeter terminated crystal. This one here is about 3/4 the size of a brick. But it's been reported from another deposit recently, I think, if I'm not mistaken, in Germany, but by far, the Kalahari Manganese Field ones are the best in the world by far. And literally thousands of these came out once, not much, in fact, recently. So the best of the best. This is the Haussmannite. And if you can remember that slide I showed you of those columnar, sort of 6-sided type of crystals, you can see this is typical Kalahari Haussmannite, these pagoda type of crystals, very different to what is shown on the stamp. Here, this particular one is shown with andradite garnet, the secondary garnets. Hematite, well, with the iron formations closely linked to the manganese there, it's probably understandable that one can get secondary formation of actually very aesthetic crystallized hematite. This is one, it's about, it's 10 centimeters, so it's almost about the size of my hand. And it's the one that myself and the late Roger Dixon used on our first book. Actually, it's a complete floater. It's actually rimmed by andradite garnet and with barite crystals. So that's the association, hematite, garnet, barite. Here's another one from the Wessels mine. Again, very strange columnar pseudo-hexagonal crystals radiating out. This was a one-off find. Associated also with andradite garnet, calcite, but also strontianite, which actually fluoresces under UV light. This is another pink red mineral. It's called inosite. Rhodo is the carbonate. This is the silicate, and these were found once off again at the Wessels mine, associated with these beautiful white sprays of natrolite. And these are amongst the best known for the species in the world. Perhaps more well known to general geologists and to mineralogists is the mineral Prenight, which is really a low grade, I think it's Pampelite grade of facies of metamorphism that is quite common globally. But interestingly, the Prenight that comes from the manganese mines is orange. And some work that was done with co-workers Chris Harris and Harry Tsikos, we had a look at this, and it turns out there's a trace amount of manganese oxide in here, which is giving this Prenight a very vibrant and orange color. Celestine, the sulfate, these fan-like sprays of celestine from the Nchwaning 3 mine. Again, these came out fairly recently, and again on matrix down below here. It's always desirable or better from an aesthetic or value standpoint if one can have crystals on matrix as opposed to being just loose. Then this mineral, which again is rare, Schizolite. But there's an interesting detective story, and it kind of shows something about mineralogy and how new minerals are discovered and how research is done. Crystals of this pink mineral came out from allegedly both Enshrining and the Vessels mine at the same time, which is kind of bizarre to me because the mines don't link underground, and to find the same thing synchronously at the same mines sounds a bit suspect. But you know, often if the miners are collecting, they often will divulge an incorrect locality to keep it secret, for example, or not to be caught, or whatever the reason is. But anyway, these came out, and at first they were thought to be the mineral Bustamite, which is a massive pink mineral that's used for cutting and for carving. And there weren't many of these, but they were obtained by an American dealer collector who took them over, who actually received them in America and took them to the Denver show in America. And they were sold there as Bustamite. But then one of the purchasers of them decided to have a look at them and analyze them properly. And it was found that they appeared to be a member, they were not Bustamite, they appeared to be a member of what's called the pectolite or the sarandite group of minerals. And it was a new species. So there again, a new species discovered in the manganese field. And it was named Marshall Susmanite after the collector semi-dealer Marshall Sussman, who actually obtained quite a lot of these and who then offered them in the American market. Marshall Susmanite. But as luck would have it, now the International Mineralogical Association has to approve new species, but some more work was done by the authors you see here down below. And it was discovered that there was already in existence a mineral known from the early 1900s from Greenland called Schizolite. And when that happens, and it's an approved species, and then that species mineral is actually grandfathered. It becomes the official name. And it turned out that these that were thought to be Marshall Susmanite were actually Schizolite. So the work that was done either didn't know this or discover that, so it had to be renamed again. So that's the long story of the detective trail between Bustamite to pectolite to Marshall Susmanite to Schizolite. Then Sugilite is quite well known. It's a purple mineral. It's used often for cutting and for carving in these objets d'art. Here's a free-form piece. Sometimes, very rarely, it forms these tiny purple crystals, which are very rare. This is a piece that's been and it kind of reflects the tectonic history of the deposit. It shows some of the Sugilite interlaying with this highly folded iron formation. And here's some fibrous variety of the Sugilite from, this is Enshrining 3 mine. Most of this Sugilite comes from the Vessels mine. Here's the finest crystals in the world of gem quality Sugilite. That's an 8mm crystal. It's not big, but it's the largest known for the species. So that's really some of the more iconic. Then I just want to close off by showing you something about these two more recent type of minerals, again, which have obtained global fame, mined by Paul Balier during his time at the mine, basically Shigaite and the Olmite. Shigaite is a mica-like mineral. You can see it's six-sided. Here's a Kalahari specimen on the cover of the Min record. Here's an article we wrote in the Lapis magazine, a new find of Shigaite from the Kalahari Manganese Field. It's basically a aluminium, a manganese hydrated sulfate with other alkalis in it, named after the Shiga prefecture in Japan, I think. And the other localities are actually almost non-events compared to these crystals that came out from the Kalahari. And in fact, Cooper and Hawthorne used the Kalahari Shigaite to define the crystal structure of the mineral, and that's their paper there. And this is a specimen collected very early in 1993. But Balier, in his contractual mining agreement, opened up an old zone in Enshrining 1, and here's a view of it underground. So there's the hanging wall, that's the face, and the white blobs you can see on the face here are actually pockets of the secondary minerals, some of which are hollow and may contain free crystals, some of which are completely filled with secondary calcite, etc. So this is the zone where they came from. And here's a close-up of one of those. So this is almost a 4-centimeter cavity or vug, and it's lined with, that brown is the Sussexite. It's then coated with druzy rhodochrosite, and here in the center sits an orange crystal of the Shigerite. And these are just some examples of these. The finest in the world by orders of magnitude of all others. Some are known from Australia, from one deposit. Some are known from a locality in America, but they do not get anywhere near the ones from the Kalahari. This is one of the largest known, 2.8 centimeters, in these parallel stacked layers of crystals, quite aesthetic. Here's a cluster intergrowing perched on rhodochrosite with tiny Shigaites on the side and with a little barite crystal on the side. And in fact, these barites came out occasionally with the Shigaites. And it was found purely by chance on the reverse side of one of the barites with these tiny little sprays of this brown crystal that we had analyzed because it looked different. And it turned out to be a manganese phosphate called gatehousite, extremely rare, even from the Kalahari, not just from elsewhere in the world. So rare species. So that's the Shigaite. The olmite is also a bit of a detective story. There is another species from the Kalahari called Polderfartite, named after Ari Polderfart in honor of the work he did on a lot of the igneous rocks in South Africa. And it's a type species. Polderfartite is a type species for the Wessels mine. And when some of these other crystals started coming out in about 2000, from 2000, 2001 onwards, they were thought to be Polderfartite. And that was the first idea. But again, a bit like the Schizolite, a bit more work was done by the Italians, Pagano and others in Italy. And they discovered that it wasn't Polderfartite, but there was manganese in it that was actually present to allow it to be a new species, which was called olmite, named after Professor Olmi. Now, the thing is, you cannot visually distinguish these two species. You have to analyze them to look at their chemistry. But let's have a look at these. So here's Paul Balier, hard at work underground in one of these, of the faces. And there's a little vug that you can see some of the rhoda in there. And I always like to tell these collectors that one sees when they're looking at a mineral and they see this beautiful shiny crystal on a glass shelf in a display case at some big glitzy show, and there's a price on it, and wow, it's expensive, but the work that goes behind this is laborious. Okay, so here's a cavity showing the olmite, and it's these creamy colored spheres or balls with a Hamerford scale. And an MSc thesis is about to be submitted to Rhodes University by Alicia Opperman, who did her MSc specifically on the mineralogy of some of these olmite vugs. So we're looking forward to that. Here's another one of these vugs, hand for scale, and you can see this sort of chocolate brown colored olmite crystals, and down here as well. Now it's quite astounding because this is a zone in the mine that produced a plethora of these crystals. And it's the type locality, and it's still unique to the mine. It's still not been discovered anywhere else after 20 years. Another close-up of a pocket olmite with these white fibrous balls are a mineral called Bultfonteinite. Type locality, the Bultfontein diamond mine in Kimberley, but in fact far more common here in the manganese mines, and some calcite and some celestine. Olmite comes in many guises, bow tie shapes, beautiful translucent orangey red balls looking almost like rhodochrosite actually. And these here as well, spheres, this is one of the largest known, that's almost the size of, it's a bit bigger than a cricket ball, I think, if I remember right, very gemmy. Chocolate colored olmites coated with a thin transparent overgrowth. This could be olmite and polderfartite together, one has to be careful. These, which look almost like eyes with some cores, with some enrichment, maybe slightly more manganese giving that color. And then euhedral crystals. This is a 4 centimeter complex crystal on matrix with some calcite and the Bultfonteинite. And another one with calcite. So very aesthetic. And the last one with sprays with ormeite embedded in the celestine. All right, so just to end off, to maybe tell you that as of today, I checked today with the IMA, there are 28 type locality species from the Kalahari Manganese Field. And that's quite something, 28 species from these mines. But what's even more interesting, or maybe astounding is to exaggerate, but interesting, is that many of them come from what Gypsum and others call the Sugilite assemblage of minerals. You know, that's that vessel's alteration event where there's this whole suite of minerals, amphiboles, garnets, manganese olivines, pyroxenes, iron ore. So this is like the Sugilite assemblage, and you can see down here some of this, this particular Sugilite with the apophyllite. But of the 28 type species, 14 come out of that assemblage. And here's the list here. The chemistry is quite onerous, but all of these come from that Sugilite assemblage. And here's a little polished square of about 2 centimeters. But if you just look at the chemistry, there's a commonality. If you look, there's barium, strontium, alkalis, strontium, coming all the way down. And in fact, the most recent one that was just discovered last year, 2 of them actually, was hydroxymaglasonite, named after Jim McGlasson in America, and yuzu zhangite, named after a Chinese academic. So I thought maybe to end off, look, some of these type species are named after people, some are named after localities, and some are named after their composition. So I thought maybe just to show you 4 of these that are named after local people in our community. And the first is Dr. Ludwig von Betzing, of which this mineral von Betzingite is named in 1986. Now, von Betzing is a very astute collector. I mean, he's a medical doctor, he's retired. But he actually obtained these blue crystals from someone, a dealer, and they thought they were copper sulfate, but he realized there was something different with their structure and their composition, so he sent them overseas, and sure enough, it was a new species. So he was actually critical in fact, discovering it. But he, in fact, has been instrumental in discovering, I think I checked last, 5, if not 6 of the type locality species through his own observations of seeing things that look different, and let's have them analyzed. It's also interesting because when he was a youngster, they lived up in the Leidenberg area. And if you want to Google something archaeologically important, he discovered the Leidenberg heads, the terracotta heads that he found while he was hiking around in the hills, which are now in the University of Cape Town collection. So Ludi is an important person for Kalahari mineralogy. And that's also why I want to show you this, not my namesake for me, but because he discovered this. Von Betzing had permission, he was digging around on waste material at hot as hell that had been dumped there from the Wessels mine. And he picked up this particular specimen, which looks a bit like gypsum, or in fact mica, or like brucite, associated with the Sugilite. And he thought it looked a bit different, and sure enough, so he sent it off to the people he works with in Austria, and it turned out to be a new species that they decided to name after me. But again, von Betzing, he found it. Then this is Colin Owensite, named after this gentleman here, passed away unfortunately in 2020. He was a mineral dealer down in Somerset West. This is a millimeter, these tiny bluish crystals that occur with the Sugilite. Again, it's only found there, Colin Owensite. Then this young couple who run a farm, and they also deal in minerals of the Northern Cape, Tanya and Jaco van Nieuwenhuizen, and they have a mineral called Tanya Jacoite, named after the 2 of them. And it's these, again, tiny 1 millimeter orange crystals in amongst the Sugilite. They discovered the specimens, sent them over to University of Arizona, and a new species. And then this one, the most recent one, after a South African person, after Desmond Sacca, called Saccharite. These peculiar fibrous yellowy green acicular crystals found with the garnet and with the Etrangite. This was problematical. It was known to be new for many years, but the researchers battled for ages to try to get the crystallography solved. So really, that's all I have to say. So I appreciate your time. I see it's almost an hour. There are two books available. I may as well give them a punt. The one on the left is out. And the one on the right is actually still available from ASOR if you're interested. So thank you very much. And if there are any questions, I'll try to answer them. Thanks.
Thank you very, very much, Bruce. Most phantasmagorical, fascinating. John, are you going to lead the question and answer session?
Yeah, let's go. I see Lou has already got his hand up, Lou. We get the ball rolling.
Yes, thanks, Bruce. That was really great. I always learn stuff when you talk. I had
load yourself, Bruce.
I had two questions for Bruce, but for better or worse, he answered them in his last few slides, but I'll ask them anyway. And the first is, how come we don't see the more common manganese silicate minerals? So for example, the manganese olivine is called tephroite, and there's the manganese pyroxenoid, which I think is called pyroxmangite. And I don't remember the name of the manganese pyroxene, but why don't we see more of those?
Well, actually, look, I couldn't show everything, but we do get tephroite there. In fact, it's present in a massive form, but also as euhedral crystals. So it does occur, but it's rare, but it's there. We do get the manganese olivine. If you look at the ore minerals, they're really all oxides. So I can't really answer why we don't get some of the other silicates. Some of the minerals that get discovered there are all like post, the Goodsma-Bierkes era, and I mean like that gatehousite, which is a phosphate. I mean that was completely unknown. So you're right, they are rare. I can't really answer why exactly, but some are there. But maybe they, not in volume, but perhaps they have just not been found as such, and there are some. I often get the odd email from people saying, hey, you don't have this on your list of minerals in the Kalahari, and I found it, and it's a little microcrystal or something. And they're forever discovering new minerals in that Sugilite assemblage, as I've just said. It's quite amazing. It's not really answered your question properly, but we do get tephroite.
The only thing I can think of as to why they may not be abundant or maybe even absent is because of temperature. Maybe some of these manganese silicates require high temperature that this area has never experienced.
Yeah, look, I always, when we start going into that realm, I always give my disclaimer that I'm a clastic sedimentologist, and when it comes to the nitty-gritty of things like that, I have to rely on my co-workers.
Okay, Bruce.
You might be right.
And the other question I had, which you answered, is when are we going to have Cairncrossite? And apparently that's already been done, and I congratulate you.
No, thanks, Lou. It's still unique to the deposit as far as I know, so I'm unique.
Yeah.
Bruce, can you just put in text where to find your book? People want to know where they can get it. Can you just in the text box?
Yeah, well, send us a flyer, Bruce. We'll put it on our with our newsletter as well. If you've got flyers.
I was just going to suggest that it's actually completely sold and marketed by ASOR here in Johannesburg from their head office, and so they have the book, and I can tell you there are still a lot in stock. So I'll certainly do that. And I think when I last looked, the retail price, look, it's a big book, was 750 Rand, which in dollar terms for a book with all the color is actually quite cheap, but they may be selling it at a discount. But I'll do that. After this, I'll actually send you the flyer.
Okay. And Bruce, is going back to the genesis of these minerals. Are those minerals, and there must have been some geochem, and you've done dating, are they all secondary minerals being leached or sweated out of the existing manganese deposits and then reprecipitated? I mean, you know, those ages are also fascinating, particularly the young one. I mean, 90 million, there's kimberlite events.
Yeah, well, look, I can tell you off the record, we haven't published it yet, but the apophyllite age we got was about 30 to 35 million, even
What's
younger.
that? What's that?
What?
I mean, what event is that? Because, you know, if you go back to the 1,000 million years, I mean, it's sort of, you know, Namakwa, Bushman land, you know, 1,200 million years. There was a lot going on just to the west there, including, you know, that shearing, obviously, or overthrusting.
Yeah, look, that would be like that would be the supergene event. I must also say, you know, there are models of genesis of the deposit, and there isn't always consensus with the people who work there.
Yeah.
I mean, there's the school which kind of originated out of RAU, UJ, Bierkes, Gypsum et al. But then there are other researchers, you know, like Eritsikos down in Grahamstown, although he's now in Greece, but who, you know, because Gypsum in his mineralogy documented, and he could map out these zones of different minerals that crystallized out from the fault zones, depending on the different fronts as the fluids were migrating out from the fault plane. So that's the model. Whereas Harry, for example, if I understand his model, is that he thinks more of it was actually supergene, and it not necessarily related to the structures, but, you know, something permeating throughout the whole deposit. So there isn't 100% consensus about all these things, and the fact that these ages come out now, you know, spanning this whole geological evolution of the region, maybe support both. It's a bit like the Wits gold. I think there's probably a bit of both, actually.
Well, an important one, Greg Buerter tossed in. Greg, I mean, you are a young geologist that loves the young stuff, and none of us old geologists really appreciate, you know, what's gone on in much younger geological time. So your comment? Are you there?
Yeah. Some of the manganese deposits that's been looked at by the French in West Africa have yielded Eocene ages. So it's, you know, this might be in Zambia as well. So there's a whole deep weathering event, lateritic weathering event that's occurred in these areas that hasn't been well dated. It's just a few dates that have been produced.
That's also true. I mean, just to the west of us, there's that Rydale deposit, that manganese, just on the way to Ventersdorp, and that's essentially, you know, where the Karoo, the Eka, has been deeply weathered, and manganese been liberated, and they actually had an open pit mine there for low grade manganese, and that's exactly the same what you're talking about.
And never forget, I mean, you might not like our wine, but, you know, manganese mining in this country actually started down here in the Cape and the TMS. You know, we've got an old manganese mine just around the corner from us on Clarence Drive. And as you know, Bruce, it was high grade stuff as well. Not very much, but very high grade. I mean,
now, listen, as this is being recorded, I have to state for the record, I love the wine from the west of the Cape. I just don't like when you have a glass of your wine, you get something in your mouth that you think is a cockroach, but it turns out to be beautiful crystals.
Okay, we'll send you some of the good stuff.
I'm waiting.
Okay. No, I mean, it's a very mobile element, as you will know better than us. I mean, in solution, it moves very easily and quickly.
Yeah.
Bruce, care to share how many physical samples you have?
In my collection, or from the Kalahari?
Yes. No, in your
collection.
I started collecting, I've been collecting since I was a young kid with agates, you know, on the Vaal River. But the first time I ever bought a specimen was in 1975. And then I started cataloging with number one in a catalog. And I did a bit of cataloging on the weekend. I'm now up at 9,510.
Sure.
Do you have a warehouse? I mean,
now you're sounding like my good wife. No,
place we can raid.
Well, you're welcome to try. I have a separate room. It's but the bulk of my collection actually is in drawers. It's not on, you know, so for storage. And I don't have lots of big things like large, but it's secured. It's alarmed. It's got cameras. So you're welcome to try.
Fantastic. All right, other questions?
Do I have to, I can see someone's just asked a question.
Yeah, about
Do
the
you have
cabinet.
special? The answer is actually yes. I didn't have them made, but I had a friend here who was a big collector of minerals, and he had nice display cases made where the top half of the case is actually glass with internal lights, and then the lower half is drawers. And when he emigrated to Canada, I actually got these cases. So they were specially made, yeah. But I had the drawers also that I have. They were specially made with the different sizes of the drawers. So you do need to have kind of special cases, and they need to have proper lighting as well. What's the best public collection in South Africa? Public.
Well, does that include you? Presumably we can come and knock on your door.
Well, it's by private appointment. But you are. Look, for public, you have to look at the museums, obviously. And I wear the hat of the Johannesburg Geological Museum. And so my opinion, I can give you my personal opinion. And I would say at this point in time, the best public display is in the Ditsong Museum in Pretoria, which is the old Transvaal Museum, where the collection does not belong to Ditsong. It's actually the Council for Geoscience collection, the old Geo Survey, that is on long-term loan and on display there. And that's the best one. The second best is the one here downtown in Johannesburg, the Johannesburg Geological Museum. But unfortunately, that is currently closed for repairs. There was a flood there more than a year ago, and we're still busy trying to get that organized. So to answer your question, the best public display, in my opinion, is the one in Pretoria. There are others around. I mean, there are small ones. I mean, the universities, some of the universities have got, if you come into our foyer here, we have a collection, it's public, or the Blackrock at Wits, which is being revamped, or down in Grahamstown. What's the museum down there where Rose Prevec works? They have a display. But for minerals, I'd say Pretoria. Ditsong.
Yeah. And Rudy van Betsings, is he still collect, or is he?
No, he's retired. He's been retired for quite a while.
Yeah.
He doesn't actively collect anymore. No. He's not all that well, actually.
Yeah, sure. Sadly.
Look, there are private collections around. Maybe to answer that question another way, the best preserved portable geoheritage material in South Africa is in private collections, because the private collectors tend to take more care of them. It's a bit of an indictment against our municipal and our institutional collections, but from a geological standpoint, and we can have a whole talk on this,
yeah, they
are really in the doldrums, unfortunately.
Yeah. No, well, it gets back to this whole geoheritage discussion, which we've been having, Bruce. I mean, you know, exactly. when we look back at this country and what we've got, and the exactly what you just said very professionally, I mean, it's just a shame that having, you know, produced most of the world's biggest mining companies as well, we're not better endowed with these facilities.
Yeah.
Anyway, for another discussion.
Yeah. No, we all take away something from the places we worked. Well, look what I brought from Lesotho, from the tunnels of Lesotho. Quite a bit of a.
What is that?
Quartz crystal, calcite. Okay, from one of the dolerite, or the cuttings in the dolerite.
Yeah, it was from a quarry that we sourced the aggregates from.
That's quite impressive.
Yeah, quite a nice small little rock. Anyway, guys, thank you very much. Are we doing any more questions here? Thanks, Bruce. This was most fascinating.
No, thanks. Okay, and then I'll email you that brochure as soon as we're done.
Thanks. And yeah, thanks everyone for joining. Thanks for the overseas people that have joined us. Good to see some of our long-term old prospectors, Corby Strauss, and I see Graham Palmer's also been on. So how are you, Graham? Are you well? Okay.
Right, guys. Next week
I'm good, thank you.
Father of Geology.
Good.
And I hope to see most of you guys back here when Meg Krog gives us her speech at the same time, same place next week. Go well.
Okay, thanks
Thanks,
very much.
Annie.
Thank you.
Thanks,
to
Bruce.
everyone.
It was great.
Bye.
Cheers,
Bye.
everyone.